In a lot of ways, testing is a discovery process. It is not an assurance process. As good software test engineers, we're not really able to guarantee anything. And we don't write the code. Okay? We don't write the code. We work with the code after it's written, and we attempt to discover the quality of the code. Discover and report it. And this is one of the key things about our business. It requires certain kinds of traits that aren't necessarily the same traits that programmers come with. Programmers have their type of communication and their type of creativity. We have a separate type of creativity and a separate type of communication. And in order to be a good software test engineer, you've got to become a very good communicator. I explored a section of the software. I discovered the following issues. I need the following issues corrected for the following reasons. You have to develop a certain methodology to how you communicate clearly so that the things that you are finding that are important can be actionable. If I pick on you for just 1 second, I know you talked to me before about being a developer. I have no doubt that as a developer, you have occasionally opened up bug reports that were gibberish. You open the bug report, you're like, what is that person talking about? The challenge of being a good software tester is to effectively communicate technical information in a clear, concise, actionable way. Programmers do not have to deal with that problem. Programmers write code. God love them for writing code. Programmers do their work by writing really good code. And their code stands on its own. We have to write really good reports. So we are report writers. Your skill as a communicator is incredibly more important as a software tester than it is as a programmer. No two projects are ever the same in the software world. Every project is potentially different based on what's being built, who's building it, what are the constraints, what is the time, what's the budget, what's the scope of the project. Everything can be different. That being the case, the level of testing can be very different depending on what project you're assigned to. For some folks, software testing is more about simply making sure that the software works. Sometimes that's enough. I don't personally think that's the best, but sometimes that's what fits the project. Make sure the software works, we're ready to go.
Until somebody finds a bug.
Until somebody finds. So then you get into the next issue of, well, not only make sure that it works the way it's supposed to work, but let's make sure it doesn't work. Let's make sure we understand where it doesn't work or how it doesn't work. Okay? Beyond that, let's reduce the risk of using the software. Each of these incrementally takes greater and greater effort, greater and greater skill. And the absolute best is to be able to work on a software team. And I've had a few opportunities at this. Sounds like you have an opportunity to work on this. The absolute best is to work on a software team where software testing is considered to be a mental discipline that everyone follows to increase the quality of the software, where everyone cares about the quality. That's fantastic when you get there. But not all projects get there. So you need to learn your skills sort of from this layer, from this starting place, and then expand it. How can I first and foremost make sure the software works as intended? Great. Now that I've proven that, how can I now go about seeing if there are places where the software is not working as intended? Now that I've done that, how can I better understand the risks of using this software and mitigate those risks? And then last, how can I evangelize all of this so that everyone on the project team cares about quality and has the tools and the discipline to carry that forward? So as I said, there are some materials out on the drive that you can take with you. There's an article on what is software testing, why it's so hard. That's about a 10-page magazine article written by James Whitaker. Wonderful article. I have no doubt that the first time you read it, it will be too dense for you to get everything. I know that. First time I read it, it was too dense to get everything. What do you do with something like that? You read it once, you put it aside. You come back 2 days later, read it again, you learn more. Put it again 2 days later, you learn more. You read this article 3 or 4 times and you'll have a really good foundation of what's got to go on. There's a second article by James Whitaker, The Art, Craft, and Discipline of Software. And there's also this wonderful thing called the Tester's Pocketbook that I found online. There's no shortage of good resources online. These just happen to be 3 really good little articles that are worth getting started with. So I offer them for you if you're interested. Okay? At its core, working as a software test engineer is about contributing to the success of the software project and the team. At its core. We have to efficiently model and exercise the software. We have to find and report software failures. We call them bugs, of course. We need to find them as quickly and effectively as possible. And then we need to evaluate the software against both objective and subjective requirements. Objective requirements. The font should be size 10, bold, color yellow. Objective. Subjective. This software should be intuitive. Okay? Objective measurements, subjective measurements. They're both part of our job. Which one do you think is harder to evaluate? Objective or subjective?
Subjective.
You got it. It's the subjective part of our job that's really, really hard. It's the subjective part that's really, really hard. Okay? When you're dealing with subjectiveness in a technical setting, you can already see where problems can occur. Developers don't really think about things subjectively. They're very objective. My code works, my code doesn't work. You want me to fix it? Okay, what line of code do you want me to change? I don't know. I just want it to work better. Those two things can get out of sync. I like to use this as a model, and I offer this as a model for you if you're thinking about this business at all. Modern software, in my view, is somewhat like an iceberg. There's the part that's above the water that you see, and then there's the huge part underneath the water that you don't see. And I'm going to take a stab here using the 80-20 heuristic rule. I'm going to take a stab that 80% of you, as my audience, presently don't know much about the software components that live under the surface. I'm going to take a guess that most of you only know software for what you see on the screen. Not everybody, of course, but most of you. You know the user interface. You say, oh, that's the software. Well, that's part of the software, but that's not all the software. What about the APIs? The application programming interfaces. What about the interfaces to the file system and the data systems? What about the communication interfaces? There's far more going on in modern software than just what you see on the screen. Now, why is that important to understand? Testing this isn't that hard. Testing this is where the real skill is needed.
Is that what they call white box?
No, I wouldn't specifically call it white box. I wouldn't specifically call it that, although there are a variety of white box techniques that help. But I wouldn't say this is only white box. You could effectively test a lot of this with black box techniques. The core is you first need to technically understand what's going on under here. What's going on that I can't see with my eyes? How can I potentially look under the surface to see what's going on? This is technically difficult. It's part of the ramp up to becoming technically proficient in this business. The starting place is to simply understand the challenge. If I don't show you the challenge, then you can't even get started. Now that you've seen this and you can use it as a model, you can start to think more and more about how would I look under the surface and start to find. This is where we have to be able to be capable of using different tools and devices and in some ways just know what questions to ask. I don't think there's any mystery to the fact that software in general is a dynamic field. Software testing is a dynamic field. We face a lot of challenges and a lot of changes on a regular basis, including constantly changing technologies. Okay? Complexity of evolving applications. Constantly looking at the lessons we've learned so far, constantly looking at the various schools of thought of how to do things, constantly sort of synthesizing that so that we can do the best job possible on the projects we're working on. The challenges of globalization and commoditization. I'm not against globalization, I'm not against commoditization. They just present very difficult challenges for us. Okay? The challenges and the opportunities with tools and automation. And then, of course, having some understanding of the various risks and such. All I'm trying to show you here is that this is a dynamic field. You will never be bored. There will always be things changing around you that you can keep up with. Some of the hot topics in our business these days, mobile platforms, cloud computing. I've suggested a few times this crisis in security and cyber attacks. Okay? All these new sit-back devices. Okay? All of our new tablets and such. Didn't Amazon just come out in the last 2 days with a new tablet? Okay? Sit back and relax as opposed to have to sit at the keyboard all day long. Okay? Coming soon, I have an open question. I can't say for sure, but it sure seems to me like in the next 5 to 10 years, we're liable to be opening up a brand new world of litigation related to software failure. We all rely on software a lot. It's everywhere. If software fails, I have no doubt that the lawyers know about it. And what do lawyers do when they know about problems? They try to go after who caused them. Okay? I can't guarantee this is going to become a field, but it sure seems to me like things are lining up in such a way that in the future there's going to be more and more call for folks who understand software in such a way that they can speak to the failures of software in a litigation setting. You mentioned it before, okay? The shifting roles and responsibilities in how software is being built, including things like agile development. And I know I've scared you a little bit, I'm sorry for that, but this whole issue of programming skills required even for entry-level test engineers, okay? I mean, that's not a debate anymore, it's part of the game now. If you guys are all able to go out to Craigslist or whatever other type of posting site you want to see kinds of jobs that exist, and you'll notice that most of the software test jobs look for some level of programming.
They want you to be an engineer, a real engineer with degree from university.
In many cases they do, yes. In many cases they're looking for you to be a computer science, have a computer science degree and then a background in testing as well. Yes, that's true in many cases. I can offer you this from an anecdote perspective, from sort of a being out there on the front lines recruiting people perspective. It's very nice to ask for a CS degree, folks. It's very nice to ask for that. But experience and capability always trump that. So when two candidates sit there and one candidate has a lot of experience and another candidate simply has a degree or maybe, you know, it's going to be the experience. Okay? So that's a little bit about the history of our profession. Always takes a little longer to go through this. Okay? I did walk you through the roadmap already. Okay? I've walked you through a little bit of this.